Hello everyone, this is Sriharsha Poluru and today I'm going to present my project Emotion Detection and Recognition using Fisher Faces method for the course Pattern Recognition. The instructor for the course is Dr. Wu. So let's begin. Before going into the problem, let us first discuss the problem statement for emotion recognition. If you are given a still or a video image of a person, you have to identify the emotion displayed by the person. The statement seems simple enough, but this problem itself is made up of two more problems or dependent on two more problems. The first is you have to detect if a face is present in an image, and the second is locate the face, and then comes the analysis of the expression. Now, in this project, we concentrate on the expression analysis aspect of the problem. Now, let us discuss the main motivation to study facial expressions and the emotion detection. The first thing may be cited as its applications. The facial expressions and the emotion detection has applications in many fields which we are going to discuss with the further slides. And the second one reason is recently there have been huge advances in face recognition and face detection fields. So this subsequently gave a huge surge to emotion recognition too. And the third reason is availability of cheap computational power. Maybe a decade or two ago, the cheap computation power was not available. But now, people are able to train models using deep networks, neural networks, so that they give better efficiency. As discussed in the previous slides, let us discuss some of the applications of the emotion recognition. One application is in the medical area is detecting diseases. Emotion recognition is used to detect diseases such as Parkinson's, Huntington's, etc. In the field of education, there are some projects which use emotion detection to understand the frustration levels and satisfaction levels of students when they are using an online tutor. We know that researchers are trying to create robots that mimic human intelligence. To do so effectively, they need to understand human emotions too. So here, the emotion recognition system plays a huge role. Now, coming to virtual reality, synthetic faces, and other multimedia areas, human emotions, in fact, facial expressions and human emotions play a major role. Now, let's move on to the methods that are available to recognize the emotions. Now, the methods that are considered here belong to the pattern classification paradigm. There are four such methods which belong to pattern classification paradigm which can be used to recognize the emotions. The first such method is correlation. Correlation is a simple method which uses the technique of nearest neighbor classification in the image space. What this means, given a test image, it tries to match to the emotional label of the image that is closest to it in the image space. Consider an image space to be points scattered all over. Now you are given a test image which is also a point, then it tries to match itself to the point which is nearest to it based on the Euclidean distance. Now this correlation method seems to be simple, and this is the only one advantage it has. The disadvantage of correlation method overshadows its advantages. One of the main disadvantages is the requirement of huge computational power and space. The other thing is, under various lighting conditions, the correlation methods fails. That is, it performs well only if there is uniform lighting, and this is not the case in most of the real applications. Now, seeing this drawback, the next thing the researchers did was to come up with methods that reduce the dimensions of the image space. The one such method is eigenfaces. Eigenfaces uses principal component analysis. So, coming to principal component analysis, this tries to define an image space in as less number of dimensions as possible and covering all the variances it has. That is, it gives the direction that maximizes the total scatter across all the classes. Classes in this case is the image classes. The other such dimension reduction method is Fisher faces. The difference between Fisher faces and eigenfaces is that Fisher faces is based on linear discriminant, while eigen is based on principal component analysis. The one drawback of eigenfaces is that it stores unnecessary information, that is, lighting variations or other informations that are within the class, that is, the information that is scattered within the class, which is not required. The main advantage of Fisher faces is that it tries to maximize the ratio of between class scatter and within the class scatter. The between the class scatter is different between different images, and within the class scatter is differences in the same image due to lighting conditions or any other such. The fourth and the final method is the linear subspaces. Now linear subspaces is based on Lambertian surfaces. Now Lambertian surface is one whose apparent brightness is same when viewed from different angles. So linear subspaces is a method which makes use of this property of Lambertian surfaces, and it constructs 3D bases from 3 or more images taken under different lighting conditions. Now one main disadvantage of a linear subspace is that the space is occupies, because each image that is to be analyzed requires at least 3 images of different lighting conditions. Now let us compare these 4 models in 4 different categories so that we can choose one model for a project. Coming to lighting variations, we see that correlation and linear subspace fails to perform well, while on the other hand, the eigenfaces and the Fisher faces perform relatively well than correlation and linear subspace. Now coming to facial expression, we see that all of the 4 methods perform well. Now here in the facial variation, it was assumed that all other factors were constant. I mean, they had uniform variation, they did not have any occlusions or obstacles in front of the face, and the images were all used in a standardized format that is similar to the training set images. Then in this scenario, all the 4 methods seems to perform well. Now coming to the computational cost, as we discussed previously, correlation and the linear subspace fail to perform well. It may also be noted that correlation and linear subspaces also occupy large space when compared to eigenfaces and the Fisher faces. And finally, a variation in facial expressions, lighting, and a minor occlusion such that eyewear is considered. Now we can see that correlation, eigenfaces, and linear subspaces do not perform well, and Fisher face outperforms all the other 3. So based on this comparison, we see that Fisher faces perform well in most of the conditions. So for this project, Fisher faces was chosen as the correct method. Let us discuss Fisher faces in a little detail. As observed previously, Fisher faces is derived from Fisher's linear discriminant, and hence is a class-specific method. What do I mean by a class-specific method? A class-specific method uses the information available within the class for the classification, such as class labels, and in this case, it is emotion labels. Now, Fisher faces is one such image representation that helps in making classification easier. Now, this method's main advantage is that it maximizes the ratio of between class scatter and the within the class scattered. That is, it does not store unnecessary information such as lighting variations or occlusions, etc., which helps to determine the emotions efficiently. Now, how do we calculate Fisher faces mathematically? To do that, let us consider there are a set of images, lowercase x1, lowercase x2, and so on, lowercase xn, forming an n-dimensional image space. And let these images be scattered or belong to a class uppercase x1, uppercase x2, so on, uppercase xc, where c is the number of classes, and each image belongs to any one of the classes. Now let us denote the between class scatter with s sub b and within class scatter to be s sub w. Then the between class scatter can be denoted by this formula, and the within class scatter can be denoted by this formula, where mu I is the mean image of all the images in a class uppercase xi, and ni is number of images in the class uppercase xi. and xk is an image in n dimensions. So the main aim of the Fisher phases is to reduce the dimensions from n, and the Fisher phases chooses the optimal projection W sub opt such that it maximizes the ratio of between class scatter and the within class scatter, and it gives a eigenvectors, m eigenvectors, W sub 1, W sub 2, so on, W sub m. And it is interesting to note that m is less than n, which is the number of images. Hence, we can say that the dimensions of the image space has been reduced. The relationship between the eigenvectors W sub 1, W sub 2, so on, W sub m, and the generalized eigenvalues gamma sub I can be given by this formula over here. Now, coming to the implementation of the project uses the Fisher phases method as the crux to detect the emotions. Now, the steps that I used to implement the project are as follows: pre-processing and organizing the data, training the model, testing the model with real data, and emotion recognition from webcam. The three steps over here, training the model, testing the model, and testing the model with real data, can be grouped as teaching the model. That is, in these three steps, we try to teach the model how to recognize the emotions if a new image is given. In our implementation, the training the model and the testing the model is repeated or iterated for 10 times to better teach the model. Now in the further slides, the implementation steps are discussed in detail. The language used for the project is Python with NumPy modules, and we also used OpenCV module, particularly Fisher phase and Haar cascade modules of the OpenCV. The dataset that is used was CK plus dataset. Now this dataset consists of annotated pictures, that is labeled pictures with different emotions. And now we pre-process the dataset into different folders so that we can use the pictures efficiently and as required to our project. Training and testing. Training and testing use the same dataset that was obtained, that is the CK plus dataset. Now 80% of the dataset was randomly selected, and this was used as training set, and the remaining 20% was used as testing set. Now this was repeated for 10 times, and each time randomly picking 80% and the remaining 20% to be the testing set. Now thus trained model is finally tested with the real images from the web. So this step was necessary because all the images that were tested were standard images. So real applications do not give us a standard image all the time. So we wanted to test the real efficiency of the model. So we went with testing the model with the images available on the web. Now the final step is to recognize the emotion from a video. So we fire up the webcam and the video image is given to the model. Now the job of the model is to detect the emotion that was displayed in the video grab. Now this model also recognizes if there are two faces in the same frame or three faces. Now the results were pretty good, and it is interesting to note that we had two types of evaluations on the same dataset. In the one type of evaluations, we used 8 categories of emotions such as anger, disgust, contempt, fear, happiness, sadness, and in the next evaluation we used only 5 basic categories. So when 8 categories were used, it gave a success rate of 69.3%. At a first glance, this number seemed to be too less, but it's not the case. Now suppose that our model didn't learn anything, that is, all the classification and the recognitions it does is purely by chance, that is random. In such a case, we can expect 12.5% of our images to be labeled correctly, but the 69.3 state that it is the model is almost 5 to 6 times better than the average case, which is a good thing. Now when the categories has been reduced to 5 basic emotions, the success rate increased to 82.5%, and in this case the average was 20%, which is 4 to 5 times more than the average, which is a good thing. Now coming to the real data set and using 5 basic emotions, the success rate was 61.6%. Now this number is not an indication of the failure of the model. Let us look into different conditions that may have led to possible drawbacks of the model. The first and the foremost thing is problem is itself complex. The facial emotions cannot depend on a single factor. The facial expressions depend on all these factors: mental states, non-verbal communications, verbal communications, and many other factors. So we cannot pinpoint the emotions to a single facial expressions. And the next thing is extreme lighting conditions. The real images that was picked up from the web were not standardized. That is, they might have a low lighting, extreme lighting, overshadowing, or any other features. And the next thing is images not being frontal. What do I mean by this? Now, in all the testing images, all the images were facing the camera, as displayed in this picture. But if the subjects were to face in any other directions or any other angle, for example like this, the model would be confused because it's trying to search for some features which it cannot find. And the last and the final drawback or the possible setback would be occlusions. It may be makeup, headgears, eyewear, and other such things that can confuse the model. Saying this, it doesn't mean that the model is bad, but it has some drawbacks which can be overcome by many other methods. Now let's look into the project demonstration. Now here, as observed before, we process the data set. Now this piece of code here is exactly what we do. Now we create two folders, source underscore emotion and source underscore images. Now this folder consists of all the emotions that is the emotion labels that are in a textual format, and this folder here consists of all the images which display the corresponding emotions. Now these two are further stored in the sorted data set, where the sorted set consists of each subfolder for each of the images. So all the images corresponding to one emotion go into a single folder. Now we find that when we extract the face, and if the input to a model is only a face, then the model's efficiency is increased. So to facilitate this, we extract the faces and store this in the sorted set. Now hence finally the sorted set consists of subfolders for each of the emotion, and each of the subfolders consists of all the images corresponding to that emotion. Now the next step would be to teach the model. To prepare the model to recognize emotions, we sort the sorted set images into two categories: training set and the testing set. As discussed before, the training set would be some percent of the sorted set, and the remaining percent would be the testing set, and this is done for about 10 times to better train the model. So after training this model, the model is stored in an XML file such as this, emotion detection model.xml. So whenever we want to use this model, then we call upon the XML file, and then we provide an input which can be an image or a video image. Now finally, this piece of code here is what fires up the webcam and then provides the images to the model for recognition. Particularly this piece of code here, this one calls the model, and then this piece of code here provides the model the necessary input. Let us test the working of the project. Now as we can see here, as I move and as I wave my hands around, the model is confused because it cannot read my face properly. But I'll try to be still, and then maybe I can get a neutral face. Now let's try for the happy face. Now maybe angry face. Maybe now a surprise face. So this concludes the demonstration of the project. Now, as we saw there, the model was getting confused sometimes because as I was talking, my lips were moving, my eyes were moving, my hands were moving, which was obstructing the images. So this is what the occlusions mean, and this is what the image not being frontal means. Because all the images that were tested, that are used for testing or used for training, the images were still, they were staring at the camera, and there were some ideal conditions. So in the real-time applications, the model may falter, but it's still good because it was able to detect all the images that I was trying to display. Now coming back to the conclusion, to conclude, we cannot say that the problem of emotion recognition cannot be solved, but we can at least say that emotion recognition problem can be solved efficiently by many other methods. Maybe the efficiency is not near human, but it is still a good efficiency. We cannot claim that Fisher face is the best because there are many other conditions which we didn't consider. Nowadays, deep learning and neural networks are being trained to detect emotions that give efficiency, and sometimes the efficiency is near human. We can claim one thing conclusively, that emotion recognition is a complex process and it depends on many other factors, not just facial expressions. Saying this, our immediate future task would be to accommodate various lightning conditions. As we saw, the ideal conditions are not always present in the real-time applications. Also, our model should be able to detect emotions in presence of minor occlusions. It is not good to expect a model to detect emotions in the presence of major occlusions such as headgear, scarves, caps, etc., because it is impossible even for human beings. So we need to train the models so that they can detect emotions in presence of minor occlusions. Now the other thing would be to incorporate different factors other than just the facial expression, that is voice, gesture, so that we can recognize the emotions in a perfect way. So saying this, I can conclude that the domain of emotion recognition is an interesting domain, and there's a lot of scope for the neural networks and deep learning to achieve efficiencies which are near human. This concludes my project presentation. Thank you.